Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the math portion of the GRE. We've been solving math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. The problem that I'm about to do is the one that I had been doing yesterday, the problem on page number 122. Today is our day number 16. Let's turn to page number 122 and I'll explain to you what's going on in a second. Today is day number 16. Read the problem to yourself. I don't have a luxury of reading the problem to you verbatim. It's on the top of the page number 122. What's going on here is that we have two departments, Department X and Department Y. We are told that the average salary in this firm in Department X is $25,000. The average salary for Department Y is $35,000. We are also told that Department X has more than twice as many people. It has more than twice as many people. Now yesterday we solved this entire problem and we came to conclusion that the question simply was what could be the overall average for the firm, and we came to conclusion that the overall average for the firm could be either $26,000 or $28,000, but it cannot be $29,000 or $30, $31, $32 or $34. So we ruled out all the other answer choices. The answer is A or B. That's what it is. It has two right answers. The overall average could be $26,000 or $28,000. What we want to do today is to find out exactly what the proportion needs to be of the workers in the two departments in order for these averages to come out to be true. In other words, we know that there are more than twice as many people. Department X, we know that Department X has more than twice as many people, but we are asking ourselves exactly how many more? What is exactly the ratio between the number of people in Department X and number of people of Department Y if the overall average for the entire firm happens to be $26,000? So let's find out. Exactly what needs to be the ratio of people in X versus people in Y, people in Department Y, if the overall average is exactly 26K. That is the question. So we're going to solve for this weight. We're basically figuring out the relative weights of the two departments. That's what it is. It's called weighted average. We have to figure out the weights. So here's the question. Exactly what needs to be the ratio of the people in Department X versus the people in Department Y if the overall ratio, or if the overall average for the entire firm is 26,000. So here we have Department X, which has an average of 25,000, and we're going to multiply it by W. W is the weight. W is the relative weight of the people. Now when I say relative weight of the people, of course I do not mean let's find out how obese they are or how chunky they are or how pleasantly plump they are. That's not what we mean by the weight. The weight is in the sense of the weighted average, the relative importance. For example, let me explain to you before we actually solve for W. Let's say, for example, if W turns out to be 3/4, listen very carefully. if W turns out to be 3/4, what it will tell us is that for every 3 people that we have in department X, we have 4 people in department Y. If W turns out to be 1 over 2, or rather, if W turns out to be 2, simply 2, which is same as 2 over 1, this will tell us that there are for every 2 people in department X, we have 1 person in department Y. But of course, we know that this is not correct because we know from the problem that we have more than twice as many people. W would have been 2 over 1 or simply 2. The weight of 2 would have told us that there are twice as many people in department X. But we know that the W, whatever it is that we're going to find, is going to be more than 2. Let's find out. And 35. 35, which is the average for the other department. And what is the total weights that we have here? The total weight we will have is the W plus a 1. The one from here. Let me do it on the side here. A simple problem, simple example so that you can understand what I'm talking about. If there are 3 people have $20 and 1 person has $30, what is the average of the 4 people? Well, one way to do this problem is 3 people with $20, 3 people with $20, which is 20 plus 20 plus 20, that's the 3 people with $20, and 1 person with $30. And how many people do we have? We have 1, 2, 3, 4. 4 people. This is one way to do this, but this is a childish way of doing it. This is not a grown-up way of doing it. A grown-up person would do the same problem by a slightly different technique, by using what is known as the weighted average. How much weight do we assign to this 20? This 20 gets a weight of 3 because there are 3 of them. 3 of them. 3 times 20. What weight do we assign to this 30? This 30 gets a weight of 1 because there is only 1 person with $30. 30 times 1. But because it's 30 times 1, we don't have to write times 1. It's just 1, which is what is here. I could write 35 times 1 if you wanted to. It's not going to serve any purpose. Over the total number of people in the entire group. How many people in the entire group? Well, let's see. In this example, we have 3 people here, and we have 1 person here. 3 plus 1. Voila. This 3 here is your W. This 3 here is your W. So there you go, W plus 1. That's the overall average. And we want this overall average to equal exactly $26,000. That's what we want to find out. How many people do we need to have in department X relative to department Y in order for them to pull the average so much that even though the average for the department Y is $35,000, but the overall average happens to be only $26,000. In order for the overall average to be $26,000, there will have to be a hell of a lot more people in department X making only $25,000 because they're pulling all the average down. So the overall average needs to be 26, which is our answer choice A. Answer choice A. Now all we have to do is solve for W. All we have to do is solve for W. I'm going to do it on the top here because I know it's getting very crowded here. So I'm going to erase all of this thing that we do not need. Or perhaps we can continue here. It's not actually that bad. So 25 times W is just 25W plus 35 equals 26 times W plus 1. 26 times W plus 1. Now we open the parentheses. 26 times W is 26W. 26 times 1 is 26. And you solve for W. Subtract 25W from both sides. Subtract 26 from both sides. Voila. So this part is gone now. Don't get confused now. This part is gone. We distributed the 26 and it's gone. basically I'm solving for W. So here's the plus sign, here's the minus sign, it drops out. Plus 35 minus 26 is 9, and then plus 26 plus 26W minus 25W, there is the W, 26 drops out. Voila, there you go. That tells us that in order, listen very carefully, that tells us that in order for the overall average for the entire firm to be $26,000, given the fact that the average for Department X is $25,000 and the average for Department Y is $35,000, given these two facts, in order for the overall average for the entire firm to be $26,000, we will have to have 9 times as many people in department with the lower average than compared to the department with the higher average. And on the side here, I'm going to actually show it to you that the weight of 9 actually does work. I'm going to show it to you right here. We don't need this arrow anymore. Let's do it here very quickly. Well, not very quickly. We don't have to answer to anybody. We don't have to catch any train. We're going to take our sweet time. So we know the weight is 9. We're going to actually show it to confirm it here. So 9 times 25 plus the 35, which technically is 35 times 1, because for every one person in Department Y, we have 9 people in Department X and Department X. And since there are 9 people here and 1 person there, we have a total of 10 people, and the overall average is 26. The overall average is 26. Let's find out. If you cross multiply 10 times 26, 10 times 26 is 260. 9 times 25, listen very carefully, 9 times 25, and there is another 25 here, so that's 10 times 25, 10 times 25 is 250, plus another 10 is 260. Well, I don't have to do anything, I just proved it. This is a correct equation. 9 times 25 plus a 35 does equal 260. Does equal 260, because this 35 has 125 in it. 125 from here, 9 of them here, there's 10 25s, which is 250, and an extra 10 makes it 260. Voila. So the overall average would have been rather $26,000 if we had 9 times as many people in Department X as compared to Department Y, which is possible because all we are told is that Department X has more than twice as many people. Well, if it has more than twice as many people, it can have 9 times as many people, or it can have 90,000 times as many people. It's okay, because it still is more than twice as many. Let's do the second scenario. Now we're going to show what the relative weights needs to be in order for the average to be $28,000. Let's do it on the top. I don't want to erase this part here. Let's find out what the relative weight needs to be in order for the overall average to be let's find out what the relative weight needs to be in order for the overall average to equal 28K as opposed to 26K. So again, the same equation, except so we have 25,000 at the average in the first department. We're giving it a weight of W. Second department has the average of 35,000. Therefore, the total weight is W plus 1, and that has to equal 28. Unfortunately, I do need the room, so I'm going to erase this part. I have no choice. But you got it, of course, it's right here. So I need to erase this thing. So cross multiply again, so we get 25W plus 35 equals 28 times W plus 1. It's the same exact thing that we did before, no difference. Open the parentheses, so we get 28W plus the 28, and here we get 25W plus the 35. Let's subtract 25W from both sides, and let's subtract 28 from both sides. This is the negative sign, this is my equal sign, don't get confused. There's a positive, there's an equal sign here, and there's an equal sign here. Let's erase this top part so we don't get confused now. And again, same exact thing that we did before. So here is the positive 25W, here is the negative 25W, they cancel out. 35 minus 28 is 7. And then here we have 3W, and then this cancel out. Therefore, W will equal 7 over 3. Voila. W will equal 7 over 3. I'm going to erase this bottom part. This had to do with choice A. This had to do with choice A. This weight that we found, the weight of 7 over W, is choice B. The overall average for the entire firm will be $28,000 if we had, listen very carefully, if we had for every 7 people in department X, 3 people in department Y. I'm going to say it one more time. If the relative ratio of the number of people in department X, that's what this is, the relative weight, relative ratio, same thing. This tells us that if for every 7 people in department X, if we had 3 people in department Y, and if the average for department X is $25,000 and the average for department Y is $35,000, and then in that case the overall average will be $28,000. We're going to show it here just like we did before. We confirmed it. We're going to confirm this part right here. So now watch what happens. So now the first weight, instead of 9, it will be 7. The second weight, instead of being 1, it's going to be 3. And now we have 7 people plus 3 people. Oh, it's still 10. What do you know? It's still 10. 7 plus 3 is 10. And the overall average, instead of 26, it will be 28. So this quantity, instead of being 260, it will be 280. And let's find out what this gives us. Let's find out what this gives us. I'm going to do the same thing. See if you can follow my logic. I'm going to say it slowly so that you can understand my logic. It's actually better yet, I'm going to show you this part so that you can understand my thinking. 35 times 3 is same as 25 times 3 and 10 times 3. Because basically what we're doing is, we are breaking our 35. You see this 35 here? This 35 is same as 25 plus 10 times 3. Well, 25, see this part here, 3 times 25 plus 10 is same as 3 times 25, which is this guy right here, and 3 times 10, which is this guy right here. So this is the 2, and this is the 1. So 335 is same as 3 25s and 3 10s. 3 25s and 7 25s will make 10 25s, which is 250. Plus 3 10s will make 30. What do you know? Voila! It does work. It does work. That's it. Now, here's the bottom line. I have no way of knowing who the people are, who you are, who is watching here, and how many people and so forth. I'm doing it for my own sake, because I get something out of it. That's the advantage of being a geek. But this is for learning purposes. You should have the right attitude. Solve the problem not just for the sake of solving it for the GRE, but get something out of it. Put your teeth into it. and understand it, the nitty-gritty, the meaty part inside it. This is it. Now I feel that we have done the problem the proper justice. Don't just do it superficially. And if you're doing superficially a problem after problem just so you can say that I solved 7 problems in one shot, then so be it. But when I'm solving something, I'm not solving it just so I can count how many problems I solved. I want to solve the problem until I get the satisfaction of knowing that I have understood the innards, the inside of it, the inner working of the thing. This is it. The question simply was, what would the relative average, what would the relative weights of the people in the 2 departments need to be in order for the overall average to be 26,000? The second question was, what would the relative weights of the people need to be in order for the overall average to be 28,000? Because we know the correct answer is either A or B. So we have to tick mark both A and B. Well, now we know the answer. In one scenario, we found out that the relative weights needed to be 9 to 1. In the second scenario, we found out that the relative weight needed to be 7 to 3. That's all. I will see you tomorrow on day number 17, where we'll do the next problem that you see on the following page, on page number 123. Alright? Bye now.